Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Art. In this tutorial video, I'll continue this 5129. This is the combined science chemistry tutorial. And as such, the contents are a bit more diluted compared to the pure chemistry or the triple sciences curriculum. This is for the qualitative analysis topic. So basically it's tests for cations, anions, gases, as well as flame tests of cations. So in this particular set of tutorial questions from the notes itself, I will continue on to the table which I first introduced in the previous lecture tutorials. So these are the tests for gases table, these are the tests for cations, and these are the tests for anions table as given in the paper 3, alternative to practical or practical components or whatever paper you call it in your IGCSE syllabus or associated curriculum. Those table results are given in practical or alternative to practical, but they are not given in the theory level papers such as MCQ or structured paper. In this first question, two substances, we got a solution M, solution meaning it dissolves, so it's aqueous or AQ, as we learned that in year 9. Solid is S, so this is a solid, not solution. We're told that the solution M is iron 3 chloride. Iron 3 in the Roman numeral, it means iron 3 plus, and the chloride is Cl minus. You're supposed to know this from the theory level syllabus. Chlorine being a group 7th element, so 287 from the periodic table will gain 1 electrons to become 288, and there was basically year 9 chemical structure and bonding as well as atomic structure. But since this is a practical component, you also have iron 3 Fe3 plus, you also have chloride Cl minus there from your table of ions. So what do we have here? We are going to describe the appearance of solution M. So this is the color of iron 3 aqueous. I must emphasize that this is aqueous and not the precipitate, not the solid, not the precipitate, as a lot of students, when they see iron 3, they would just want to just straight away say red, brown, PPT, because you know this is in the table. However, this is after you have added sodium hydroxide, this is after you've added ammonia. What is the color before you have added those two, sodium hydroxide or ammonia? This is a solution, so not a solid, okay? It's supposed to be a yellow solution. I show it in the tutorial, practical tutorial video part 1. If you saw that particular video, you will see within, when I tested for this iron 3 cation, the solution we started from was actually yellow to begin with. So we are told that it contains iron 3 plus aqueous and also Cl minus aqueous, which you need to test for now. Dilute nitric acid and aqueous silver nitrate. This is basically the test for halide. Halide ions are basically the chloride, the bromide, the iodide. We know chloride is present, so what is our observation? We go straight to the table. We saw that chloride, bromide, iodide, they all had the same test, add nitric acid and then aqueous or a solution of silver nitrate. With chloride, I will get a white PPT. This is a theory level set of questions, not practical, so I have to write down precipitate, white in color for the chloride, silver chloride being formed. So that is white PPT. If you want, you can spell it out in full, precipitate. Make sure you spell it properly. White precipitate forms. The next one is nitric acid and then barium nitrate. So barium nitrate there is basically the test for sulfate. So we are going to be looking straight onto the table of tests in a little bit again. So barium nitrate aqueous, that is the test for sulfate ion, SO4, 4 oxygen, 2 minus is the overall charge. Add nitric acid, add a solution of barium nitrate, you get white precipitate. If sulfate is present, you get a white precipitate. However, we were told that only iron 3 plus, only chloride is present. There is no sulfate. No sulfate. If there is no sulfate, so we don't see any precipitate. No precipitate at all. No white precipitate at all. Therefore, we say no observable change. Or some students would just say no change, no reaction. It remains colorless solution, no precipitate, also okay. If you say no precipitate forms, also okay, but no observable change. Since this is a negative test, there is no sulfate in our iron 3 chloride solution. For the next bit, we have drops of sodium hydroxide were added until a change was seen. You add drop by drop, as I shown you in the tutorial video, and then you add excess. This is the test for cations. So the cation present was iron 3 plus. I'm going straight to the table. Iron 3 plus there. I'm adding sodium hydroxide. I get a red-brown precipitate with sodium hydroxide, drop by drop. And then insoluble in excess sodium hydroxide, so it remains as red-brown precipitate. So I do get a red-brown solid. So that is your red-brown PPT forming. But then we complete the story based on the table of results. This is insoluble in excess sodium hydroxide. Therefore, the red-brown precipitate remains. Test on solid end. Now this is the solid. Now the appearance of solid end was studied. The appearance is a green powder, so it's colored. This is a colored solid, which suggests that it could be Cu2 plus, it could be iron 2 plus, iron 3 plus, but it could also be the other one, which is chromium 3 plus. These four give you colored solutions based on the table of cations. Now you heat the solid and you get a gas. When you get a gas, you have to have the test, the result, and then the identity. So they have only talked about the lime water. Lime water turned milky. This is the test for carbon dioxide, as it was also given in the table of tests for gases. Turns lime water milky by bubbling the gas into lime water. The lime water turns milky or cloudy or white precipitate. There's carbon dioxide, CO2 present there. You are supposed to name the gas. You cannot put down CO2. You need to put down the name. It's called carbon dioxide. From environmental chemistry, we know that carbon dioxide is a greenhouse gas. Being a greenhouse gas, it's an environmental pollutant. It causes global warming. Of course, we burnt a lot of fossil fuels. Complete combustion of fossil fuels will give us carbon dioxide, and that will cause global warming as a result of using too many cars or too much factory activity and so on and so forth. The next one is solid end. Unfortunately, I think this was a pure chemistry question. This is not in the combined science syllabus, so do ignore this last question. Do ignore this flame test. So this one, the blue-green color, is actually indication for copper 2 plus. This is the pure chem syllabus. So my bad for including this question here, but actually it would have been copper 2. Copper 2 because straight from the table, of course we didn't do this exact observation. I'm just saying you should name it as copper 2. And then the only anion that give you carbon dioxide gas. Carbon dioxide gas from heating the solid must have come from the carbonate, CO3 2 minus. So the name of the solid ionic compound has got to be your copper 2 carbonate. So cations, anions, ionic compound. As you know about, exchanging the valency. Valency is what you call the combining power. This was all part of year 9. Chemical formula. When we do the crisscross, we are exchanging the valency, but we can simplify this into the simplest whole number, so that we get 1 Cu2 plus, 1 CO3 2 minus, CuCO3. Or you can write copper 2 carbonate, and that will be all for this 10 marks first question here. In this second question, this student gave to students a set of 3 colorless solutions. Colorless solution means that it's not Cu2 plus, not iron 2 plus, not iron 3 plus, not chromium 3 plus, because these are all colored solution. So we have X, Y, and Z. We also have indicator. We first learn about indicator from acid, bases, and salt topic. So you can always go back to those topics if you don't know what I'm talking about. Solution P is colorless in acidic, but pink in alkaline. So solution X, you already added indicator. Solution X is colorless, meaning to say this must be acidic. Pink there must be alkaline for Y and Z. And as such, decide whether they are acidic or alkaline. X is acidic as it turned colorless. Well, it remained colorless because after colorless, it remained colorless in acidic solution. But Y and Z must be alkaline because the indicator turned color in the presence of the indicator that turned pink. S, based on the information given, we circle, we underline information as we read and process information. Part B, the students wanted to deduce the name, get the name, not the formula. We know every acid contains these cations. This is from the acid, base, and salt topic. Every acid contains H plus ion, not H, but H plus ion. You want to carry out a test. Show that the acid contains sulfate. So sulfate is basically SO4 2-. The formula will from year 9. And name the reagent that you can add to this acid to confirm it contains sulfate. We look at the table of tests for anions. So anion under sulfate, you add some nitric acid and then barium nitrate. Aqueous barium nitrate. Aqueous barium nitrate is the solution that you must add to something to confirm that sulfate is present. So name, basically get it from the table itself. It's not the nitric acid that make you precipitate out. It's the aqueous barium nitrate that eventually give you the white precipitate. So describe what they observe. So from the table earlier, you got a white precipitate. So white PPT forms. Now we know that every single acid contains H plus and this acid contains sulfate. So what is this acid that has both H plus and SO4 2-? Well, we know about formula and stuff. Of course, we know we can crisscross the valency and we will get 2 of the H plus and 1 of the SO4 2-. They want the name, not the formula. What I'm doing here is the formula. 2 of the hydrogen ion, 1 of the sulfate ion. H2SO4 is what you call sulfuric acid. Sulfuric acid will form salt. As it reacts, sulfuric acid will form sulfate salt there. Part C, the student placed about 1 cm solution Y in a test tube. Added 1 drop of P. Added 1 drop of P. So P and Y is basically going to be pink. So what we started from is pink. We start from pink color because indicator and Y, which is alkaline, gave us pink as stated in the question earlier, if we read the question carefully. Then you added solution X. After a few drops have been added, there was no change in color, but when more drops, then the color changed. The color can only change from, pink to colorless, because when you go from pink, pink was alkaline, and it will have gone to colorless when it become acidic or just neutralized. That means no more alkaline present. When we have alkaline, we have this very important ion. It's called OH minus. It's called hydroxide ion, where the pH is greater than 7, and you can test for it with universal indicator. Universal indicator will show up as blue or purple, but then you can also use red litmus paper. It will turn blue. Ammonia is alkaline. Ammonia pH is greater than 7. Ammonia contains hydroxide in water. Therefore, ammonia will turn red litmus paper blue. So this is acidic, this is alkaline. We are doing a neutralization reaction. So X is acidic, Y is alkaline. So what we are doing is we are doing salt plus water, which is essentially what you call neutralization reaction. You first encounter this in lower secondary. You second encounter it in year 9 general reactions. You third encounter it in year 10 acid and base and salt topic. And we have no change at the beginning because not enough acidic. X has been added. So Y, which is alkaline, is not neutralized yet. So you still haven't neutralized it completely. That's why there is no color change yet. It's still pink. But then when you go from pink to colorless, that is because no more alkali, and all the alkali have either been neutralized exactly by the acid from X, and I know it's acidic from the earlier questions, and I know it's acidic from the earlier information that we were told in the questions. Information give you ideas of what to expect, to be honest. Now this next table, 2 more experiments, study the observations and then suggest the names based on the observations. Now first of all, we have zinc and also sulfate. Sulfate is basically SO4 2-. We need aqueous barium nitrate. That was one of the earlier questions. Aqueous barium nitrate, and it will form white precipitate if sulfate is present. We did not exactly get barium nitrate because here we also have excess of solution Y. What was solution Y? Solution Y was alkaline. Alkaline contain OH-. OH- name is called hydroxide. The pH is greater than 7. This is most likely the test for cation. Think about your sodium hydroxide and also ammonia. In the table, we are testing for cation, which is Zn2 plus aqueous cation. If we look at the table, with Zn2 plus, we have Zn2 plus and white precipitate in sodium hydroxide, soluble in excess, colorless solution there. So what we get then is going to be, what is this solution then? The name of solution Y. Well, I can call it sodium hydroxide, and by right I should really call it aqueous sodium hydroxide because it's a solution that I've added it in. Both of them will be aqueous. This next one, we have bubbles. So if you have bubble, that means there is effervescence. Effervescence, basically from the table, this gas turn lime water milky. The gas is carbon dioxide. If the gas is carbon dioxide, it came from carbonate. It came from carbonate. If you look at the test for anion, something react with carbonate to give you carbon dioxide. And what do we know? Something react with carbonate. Carbonate reacts with acid in order to give you carbon dioxide, which was basically this general reaction here from year 9, as well as revisited again in year 10, acid, bases, and salt. Carbon dioxide, bubble the gas into lime water turn milky, the gas is carbon dioxide there. So what can I say there? There must be carbonate. But how do I decide what is the cation? Just put down something simple like sodium carbonate would do the job. Some other carbonate would also do the job, but this is solution, so there aren't really many other choices because some other carbonates are not really soluble. So some other choices could include potassium carbonate or ammonium carbonate, but you don't really do solubility rules, so not to worry too much. Sodium carbonate would do the job there. So I think I'll leave it there for these particular tutorials where I went through a couple of questions on this qualitative analysis and using the table of tests for cations, anions, and gases so far. So don't forget to click the button on the bottom right, as you will see in all the videos, to subscribe to my channel, and do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram. And do share the channel widely with friends, chat group, other people whom you think might benefit from the various tutorials on my channel, and I'll see you in the next tutorial video. Thank you for watching.